Imagine you are launching a massive property rental app designed to handle thousands of users, apartments, and bookings simultaneously. If you simply dump millions of raw names, prices, and dates into a digital bucket, your application will have no way to locate, sort, or protect that information. Computers are incredibly literal. They don't instinctively know that a phone number field shouldn't accept alphabetical letters, or that a booking date can't be set in the past. To become usable, raw data requires a rigid, reliable skeleton to hold it in place and prevent corruption. This list shows the specific architectural toolkit used to build that skeleton, SQL's Data Definition Language, or DDL. While other programming tools move information around, DDL commands establish the structural rules that define how data is stored and how various elements relate to one another. Construction begins by creating the first container designed specifically to hold staff data. This block of SQL code illustrates the blueprint for the staff table, initialized by the create table command. Declaring specific data types next to our column names, like varchar, char, and decimal, sets the exact parameters for every piece of incoming data. Varchar acts as a flexible container, expanding to fit text like a name. The char type enforces a fixed length limit for data that never changes size, like an employee ID. The decimal data type locks in mathematical precision, ensuring the database respects currency values. Defining these parameters is the first line of defense against data integrity issues caused by improper user inputs. Even with the right containers, real-world data entry remains unpredictable and prone to errors. Applying the NOT NULL constraint to a property's rental price ensures the system will never allow that essential field to be left blank. We establish absolute identity using a primary key constraint. Assigning a unique employee ID ensures two workers with the same name are never confused. A foreign key then links one record to another, connecting a specific renter to the exact property they are leasing. Without these constraints, a database operates like a disorganized spreadsheet. With them, it becomes a secure, interconnected engine for the application. As an application grows, security needs become more complex. A manager might need to see which staff manage which properties, but should be prevented from seeing their private salaries. Developers can use the alter table command to add new categories, like nationality, to the existing structure without disrupting the live system. For data that is no longer needed, the drop table command removes the entire table definition along with every row stored within it. DDL provides the essential tools to evolve, adapt, or remove these structures as a business scales. When we pull back through the glass screen of your smartphone, we leave the code behind and return to the user-facing application. Every time you search for an apartment or book a stay, you are moving along the structural tracks laid down by database developers. Mastering SQL's data definition language gives you the ability to build the structural foundation that ensures application data remains reliable as the user base grows. If you found this breakdown helpful, drop a like, subscribe, and tell us in the comments which coding topic you want us to decode in the next episode.